Hello, we'll be discussing concept of trinary search, and I will be linking this concept with binary search. So, uh, the trinary search is very similar to the binary search, but there are few differences in both of them, obviously. So, in binary search, we are given an array. Basic binary search, we are given an array, and we know that we have a left pointer, right pointer, and we make a mid pointer. And after the mid pointer, we are sure that there does not exist any solution. So we literally divide this array into two halves, and in the second half, we know that the solution does not exist, and in the left half, suppose in the left half the solution exists. So we now know that the solution is existing. So we don't go in this region at all, and we have reduced the array size to half of its size. So this is the concept of binary search. We reduce the size of the array exponentially. So first it gets half, then one fourth, so on. So very powerful. So now we know that solution might exist in somewhere between here. So again we just shift this head to this and becomes a new problem to us. So, so the function which helps us to determine whether this is very crucial in these points. Uh, compare, find out whether there exists from mid to high or low to mid, vice versa. So, so this is the concept of binary search, and code is very similar to what I have explained. So there are many implementations of binary search, but one which I love is take a mid, and mid is equal to lower plus height divided by 2. Okay, and we make a function of this function is very important, and this on um, changing with the problem. There can be a very different type of function. The function can run in n log n and anything like that. But we never prefer the function to run in n square algorithm, because then there is no point in it. So we query mid, and if the answer exists, then then we just move the right pointer to left. So suppose we query L to mid, then we move right pointer to mid minus 1. Else we move, so what we do else, else we move left is equal to mid plus 1. This is the basic approach of binary search, which you all know, the binary search. But in binary search, there is little bit what happens in binary search. So we are in binary search. Mostly, what happens is that we want to maximize, minimize answer. We want to find an answer. We know what the answer looks like, and then we want to find that answer. Um, but in tiny search, we don't know the answer itself, because in tiny search we mostly deal with the convex graphs or some monotone graphs. Basically, you know what the graph is looking like, and then from the property of the graph or the function, you should search for the answer in terms of in tiny search problems. So main difference here is that we have a graph which is a graph. It might be convex, concave, anything. So in these problems, so these problems we divide this array into three parts. This is L by 3, L plus L by 3. This is R minus L by 3, which is L by 3. I will not L by 3 plus L plus difference divided by 3 is R minus difference These are the 2 points. Difference is r minus l divided by 3. Difference is r minus l. So now these 2 points correspond to point between here and here. So there are two, three conditions which arrive in this problem. Basically, what are the conditions? Firstly, the conditions are that what should we do? Because we have a left pointer here somewhere, right pointer, graph is very symmetric. I don't want the graph is like this. So the graph is like this, and we have our left pointer here somewhere, and right there. This, let's call this as B1 or mid1 or mid2. There are two mids, M1, M2. So if now, according to the problem, the solution exists at the bottom of this graph. If M1, f of M1 is M1 is less than or equal to f of M2, and what this means that M1 is very close to the solution as compared to M2. Right? So what we should do in this case is we should shift R, not L, because solution might be just here. So, and this would create problem if we shift this, because we surely know that the solution exists from from L to from L side, not from R side, because M f of M2 is very bigger, greater than M1. So M1 is very close to this. Even if we R to M2, there will be no loss of the solution. So, so what do I mean by this is we'll shift any one of the coordinates, any one of the points, as we did in the binary search problem. But in this problem, we'll shift very sensibly, not shift anyhow, because we should look at the graph firstly. Then, in this case, the answer is shifting R. But there might be cases where answer can be by shifting L, or we can shift both of them if we want. That's scenario. It depends on scenario, but in this problem, we can easily say that if I shift R, then there will be no problem. So there was a question on brute forces, which I cannot name because there is copyright issue. I don't know. So I linked down the problem in, but it is very similar to what I have explained for the trinary search problem. But basically, the problem is we are given two arrays, those array A and array B. 1, 2, 3, 9. Sizes can be different. So the author wants the minimum of this element to be greater than or equal to maximum of this element. What author wants? Minimum of A, A of B. So minimum is 1, maximum is 9. 1 should be greater than 9, but obviously when incrementing 1, 2 will be less than 9. We have that also. So what in this case I have taken example, but if you draw this graph for this, so you can visualize this graph very similar to what I have drawn here. So I think there is no need to draw this graph, but you can also feel that there will be some answer for this, and when we are going too much below this, and what is the answer? What is the answer? This is very important. Answer is very simple. Answer is minimum. Uh, Answer is minimum of, what is the answer? Answer is, we want to fix a coordinate. We want to fix a point, uh, which will act as the answer for us. Because suppose we fix as 3 as an answer. So all the points which are less than 3 should be incremented to 3. All the points on the B array which are greater than 3 should be decremented to 3. That's the main key point in this problem. All the points which are greater than 3, this array should be incremented to that point x. We are brute forcing on x in terms of language, brute on x. Then we place that x and we check what is the answer for it. So that comes out to be a graph like this. So again, we are ending up with the scenario which I discussed earlier. This is very important. You have to observe the graph, and doing the test cases, you can prove that this is like similar. And where to brute force on, that is also. So I hope this video some clarification in binary and trinary search. Thank you for watching.